Hello. Um, Today we are starting a new chapter. We're in chapter 5, and this chapter is dominantly based on figuring out solving equations, mainly linear equations. We touched a little bit on linear equations in chapter 4, where we talked about the slope and the y-intercept and how to find both of those solutions. If you may have struggled with those concepts, hopefully we will dive in more into these equations and where you'll be able to gain a better understanding. So 5.1 is we are to write linear equations. To review, slope-intercept form is when y equals mx plus b. That's when our slope our slope is represented as m and b is represented as our y-intercept. So if we look down here, we have some examples. This is kind of what we talked about in chapter 4, but it's kind of the reverse. In chapter 4, they gave us the equation and they wanted us to determine the slope and y-intercept. Here, this example, they give you the slope and the y-intercept, and they want you now to solve the equation, use the slope and y-intercept to write an equation. So the general equation for what they're looking for is slope-intercept form, which was the y equals mx plus b. So all we're doing is substituting in the variables with our numeric value. So for a, we'll go y equals, and we have an m. So our m for this particular example is negative 5, 6. So if we substitute that in for m, we have our x, and now we'll have a positive 10, so I can write plus 10. So for a, to write the equation for this particular slope and y-intercept is y equals negative 5, 6x plus 10. As we go on to b now, we see that our slope is negative 1 and our y-intercept is negative 5/16. So we're going to do the exact same thing as we did in example A. So we'll go y equals, we have our negative 1, but we can just write it as negative x. We don't necessarily need to write the negative 1. If you do write the negative 1, that's fine. If that helps you gain a better understanding of the slope identification, I'm fine with that. Then we have ourselves a minus 5/6 as the y-intercept. So that means we can write this as a negative 5/16. So our final answer for this example is y equals negative x minus 5/16. This example, they want you to write in slope-intercept form from the given graph. Excuse me. So we were given several points. We were given points negative 3, 6, 0, negative 7, and 3, 8. So the two things that we need to look for here are the slope and the y-intercept. Now, finding the y-intercept, all we have to do is find it where it crosses the y-axis, and it seems to have crossed right here at 0, negative 7. So I can write in that our y-intercept is 7. Now, we can solve the slope equation in one to two ways. One, we can count the graph. We can look at our rise over run. So I'm going to start at where negative 3 comma 6 goes, and I'm going to count to see where it lands, where I get to here at 0 comma negative 7. So I rise up 1 and I run to the right 1, 2, 3. So that, with that being said, our slope is 1 over 3. We ran up a positive 1 unit, and we rose up 1 positive unit, and then we ran 3 positive units to the right. If you didn't see it like that, you could always remember our equation m equals y2 minus y1 over x2 minus x1. Now, we may have to use that in other problems that doesn't deal with a graph and you can't count them, but if you have a hard time finding the slope through counting the graph, this method also works. Let's give it that a try. So I'm going to use the values of negative 3, 6, and 0 comma 7. So I'm going to use 7 as my y2 minus 6, which is my y1, divided by 0 minus a negative 3. So since that's a negative and a negative, I'll make those a plus. So 7 minus 6 equals 1 over 0 plus 3 is 3. And so that gives us the same slope as it was counting the graph. Now all we have to do is plug in our newfound slope and y-intercept into our y equals mx plus b equation. So for this particular example, y would equal 1/3 x plus 7. Going off of this equation, again, we are still looking for the y-intercept form, and our y-intercept in this case lands at 0 comma 3, so our y-intercept would be at 3. And I'm just going to count the graph to find the slope. So I'm going to start with 0 comma 3, and I'm going to see where it lands at 2 comma negative 2. Okay, so I'm going to rise down 1, 2, 3, 4, 5 units. So I went to a negative 5, and I'm going to run to a positive 1, 2. So our slope for this graph will be negative 5 over 2. So now it's just a matter of substituting in our values into our equation. Okay, this example, they're asking us to write the equation of the given points. This time they don't give us the graph, so to find the slope, we must use that equation m equals y2 minus y1 over x2 minus x1. In these two values, they do give you the y-intercept. Can you guess which coordinate they're talking about? The one that they're talking about is this one, 0 comma negative 2, because our x value is at 0, which means that that point is on the y-axis, and so that gives us our y-intercept. So our y-intercept, for our example A in this case, would be negative 2. Now all we have to do is plug in the values from those given coordinates to find our slope. So I'm going to use y2 as negative 2 in this case, minus 4 over 0 minus negative 9. And negative 2 minus 4 will give you a negative 6. And this is a plus and a plus. So 0 plus 9 will give you 9. And since this is not in lowest terms, let's put that in lowest terms. Lowest terms would then give you negative 2 over 3. So our slope for this equation is negative 2/3. Our y-intercept is at negative 2. We plug these into our equation. Y equals negative 2/3 x minus 2. Okay, B seems complicated just because they seem such large numbers, but it's really not all that bad. Again, I look at the two values. I see that we have a 0, 100, which then gives us a point at the y-axis. So our y-intercept equals 100. And we have to plug in this equation, use this equation to find our slope. So let's do that. So we have m equals 100 minus 1,250 over 0 minus 500. So 100 minus 1,250 will give you negative 1,150 over 0 minus 500. That gives you a negative 500. And since I have a negative over a negative, I can make those positive. And let's put this into lowest terms. You can divide both of them by 50. And if you take 1,150 divided by 50, that gives you 23. And 500 divided by 50 gives you 10. So our slope for example B is 23 over 10, and our y-intercept is 100. So plugging these in to the original equation, we will have 23 over 10 x plus 100. Let's see. This one, I need some room there. Okay. Now it says write a linear function f for the given values. Now you see you're given where f of negative 4 equals 11 and f of 0 equals 3. Now that may sound complicated, but if you remember from chapter 4, where I think it was 4.7, where we evaluated linear functions, like for example, do you remember when we used f of x equals, say, like negative 6x plus 5, where x equals 2, for instance, and when you plugged in, you had to substitute 2 in for x, so you had f of 2 equals negative 6 over 2 plus 5. And that gave you what? F of 2 equals negative 12 plus 5, which would give you a negative 7. So in writing it like this, our coordinates here would be 2 comma negative 7. So what they've already done is they've given you the results of what the function would be if x equaled negative 4 and x equals 0. So we can rewrite example A as, so we have f of negative 4 equals 11, we can rewrite that as negative 4 comma 11. Coincide, we can do f of 0 equals 3. We can rewrite that as the coordinates 0 comma 3. And now, since we have them in coordinate form, we can now solve the slope and y-intercept to get our equation. So if we have this coordinate here shows us that 0 comma 3 lies on the y-axis, so we can determine that our y-intercept equals 3. And now we just use the equation for the slope to find our slope. So I'm going to take 3 minus 11 over, I'll put the m there, 0 minus a negative 4. So 3 minus 11 gives you a negative 8 over, so this is a negative and a negative, so we'll put the plus here, and this will give you a positive 4. And let's bring that to lowest terms. Negative 8 divided by 4 will give you a negative 2. So writing this equation, we'll have y equals negative 2x plus 3. And if they want you to write it as a function, you can write it like f of x equals negative 2 plus 3. I'll accept both answers. Okay, last example. We have f of x, or f of 0, I'm sorry, equals negative 31. That can be written as 0 comma negative 31, and f of 10 equals 91, and that can be written as 10 comma 91. So we see that this equation, or not equation, this coordinate lies on the y-axis, so we know that y-intercept equals negative 31, and now we just have to use our slope equation to determine the slope. So I have 91 minus a negative 31 over 10 minus 0. And so this is a plus and a plus. And 91 plus 31 is 122 over 10 minus 0 will give us 10. And if I were to put this in the lowest terms, both of them are divisible by 2. So if I took 122 and divided it by 2, I'd get 61. And if I took 10 and divided it by 2, I would get 5. And so that is our slope. So I can write this as y equals 61 over 5x minus 31. Or if they want you to write it as a function, f of x equals 61 over 5x minus 31. And that is the lesson on writing equations in slope-intercept form. I hope this helps. Until next time.